Hi, I'm Don Wei. I'm an ARM fellow. Today, I'm going to be talking to you about a program that makes ARM devices just work. This is called ARM SystemReady. Well, so I'm going to go back and do a little bit of an overview for a program that we have run before. This is the server ready. And then we're going to talk about how we extend beyond the servers. And this is the System Ready program. So the server ready, we have launched the program 2 years ago at the TechCon and carries the vision of making the software just work on ARM servers. And the components of that program is basically a couple of specifications plus a test suite. So we have what we call the SBSA and SBBR specifications. These are the specifications for the minimum requirements for hardware and firmware that make some of the operating systems like Windows, Red Hat, VMware, and many other Linux distros to just work on ARM servers. And then we also developed this test suite called Architecture Compliance Suite, ACS, that helps to test the silicon vendors' reference boards and OEM ODM boards for the compliance to these two specifications. And the test suite is actually open source, and it is on the GitHub with the Apache v2 license. And the way we develop the specification is that we utilize the Mantis 2 and the Causeway facility to work with almost 50 companies, anywhere from the silicon providers, OSVs, IP providers, OEM ODMs, BIOS vendors, hardware vendors, and hyperscalers. We're adopting this standards approach for maximum compatibility and consistency. So this server AC program, once the specifications are developed and once the systems are ready, we have ODM managers that would work with the partners to get the test logs after running the ACS. And then we have teams inside of ARM to review the log feedback, and then we have the architects to do the final approval of the results. And if the test results are satisfying, then we work with the vendors, the partners, with our marketing teams to communicate and share the certificate and do the co-marketing of this program. And so in that case, for the server case, we have many of these operating systems just work. So we accomplish the mission that we started with. And the Microsoft and Red Hat people were quoted here as well. And so now the new program is that we're going to be extending this server ready program beyond the servers. And this is what we call ARM System Ready. And the mission is to make software just work, this time on ARM-based devices, not just servers, especially in the embedded servers and IoT. Basically, these are the industrial edge and IoT space. And we have a program called ARM Project Cassini, and System Ready fulfills the foundation for the standards part of the program. Project Cassini also covers security and cloud-native application ecosystem. The vision of this System Ready program is that you can land the common OSs on various different hardware from different silicon providers and OEM ODMs. And the key vision here is that software would just work, right? So ARM System Ready is a foundational compliance certification program that we do for and with the ecosystem. We build it on top of Server Ready, together with the ecosystem, and then we set the standards for a broader set of devices. Our vision is for software that works seamlessly across a vibrant, diverse ecosystem of hardware. We would focus on the common components of the software stack, the operating system, the hypervisors, and the middleware components, so that these would just work. And this way, we enable the partners to focus on innovating and deploying the differentiating application layer of the software. So our focus is establishing a more uniform hardware system architecture and consistency around key processes like boot through our standards approach. This way we can bring to simplified and faster time to market for our partners. And as I mentioned already, SystemReady is the foundation of the Project Cassini project. And the way we do it is very similar to what we did for the ServerReady. And in this case, we have split the hardware specification into two pieces. One is the base system architecture, BSA. This is documenting the minimum set of CPU and system architecture, including PCIe integration. And then the supplement that we do for different markets are going to be matching the progression of the CPU architecture. And then the firmware side, we are now doing a new specification called Base Boot Requirements, BBR. This way we can expand and include a common set of firmware interfaces by doing additional inclusion. And at the same time, we recognize the different software stacks may require different recipes. So we put it into this visual diagram, right? So if you're familiar with the original SBSA, what we are doing is basically we extract the common pieces out of the original SBSA document and put it into the BSA. And this one is the minimum subset of hardware needed to boot and run an operating system. And we expect this to be mostly stable, so we don't necessarily do an annual cadence updates for this part of the specification. But then the rest of the requirements that we have in the current SBSA, we put it into this new SBSA supplement. And then we can continue to define future levels or new revisions of the document based on the progression of the CPU architecture. And then we can also do additional supplements for different markets as well. On the firmware side, the SBBR that we had for the server market originally addressed this middle piece that, you know, it works very well for many of these operating systems that are shown in the middle of this picture, right? The VMware, Red Hat, Windows, and so on. However, even for the servers, there are a few hyperscalers that are wanting to use the Linux boot model for their firmware. So we are creating a new requirements and then the recipe for these kind of operating systems that they support. And then on the more embedded systems, the traditional way is to use the U-boot and device tree firmware. And the new U-boot is also supporting the UEFI ABI. So we are designing what's called the EBBR to support these kind of devices to provide some uniformity that I'm going to be covering later on in the slide. So the way we're doing the BBR is that, we're going to be listing a number of standard firmware interfaces. And then based on these interfaces, we create different recipes that are tailored to different OSs. So for example, the SBBR that is based on the requirements of supporting UEFI and ACPI, this was originally in the SBBR spec, but in this new case, it's a recipe, and it is used to support these operating systems like Windows, Red Hat, and VMware, as I mentioned before. But a number of the other OSs can support the firmware interfaces if ACPI is not there. So this is part of the EBBR. And as I mentioned, certainly the Linux boot side is not needing to support UEFI. So we have created these different recipes for different OSs. And we also created a base boot security requirements document that supports features like secure boot and secure firmware updates. So with the reformation of these specifications on hardware and firmware minimum requirements, we established this new program called SystemReady. So in this ARM System Ready, we have one program, but it contains multiple bands. At this time, we actually created 4 major bands. So for servers, you're required to conform to the hardware specifications like BSA and SBSA supplements. However, depending on which recipe you choose from the BBR document, if we choose the SBBR recipe, then it is exactly the same as what we had in the server ready, right? So we would have this SR band. And then if you choose the Linux boot, then we created this new band called SystemReady LS for Linux boot. On the Edge and IoT side, we do not require the SBSA supplement because these are the silicon that are not designed for the server usages. But also, depending on which firmware you choose, if your firmware complies to EBBR, then it is the SystemReady IR band. If your firmware is supporting the SBBR recipe, including the ACPI support, then this is the SystemReady ES. And we are also creating a couple of options, one for pre-silicon and one for security. And I'm going to talk about those later on in the slide as well. These are the options that help to make system more robust. So these are the beautiful bands, the stamps for these bands that you will receive if your system are certified accordingly. Here's a little bit more detail. So people may be familiar with the server ready. If you are, the SR band on the right-hand side is exactly the same as what we had for server ready. So on the hardware side, you're required to support BSA and SBSA, right? And then on the firmware side, you're required to support the SBBR recipe. And so basically for firmware interfaces, you're required to offer UEFI, ACPI, and SMBIOS offerings. And as you can see on the example list of the OS distros, these are the operating systems that are verified to be supported on this band. And then if for this kind of server systems, and you choose to support Linux boot as the firmware, then you move all the way to the left-hand side. This is the LS band. The only difference is really the firmware is Linux boot. You're still required to provide the ACPI and SMBIOS, but you don't have to support UEFI. And some of the hyperscalers, as I said, prefer this approach. And we are supporting that. And in yesterday's session on Linux boot, I already talked about this band as well. And for the Edge and IoT space, the middle 2 bands are of interest. And so in this case, on the hardware side, you are required to support the BSA spec compliance. And then on the firmware side, again, depending on which band you are going to be supporting, you can supply different firmware, right? So for the systems that are supporting EBBR, basically you're offering UEFI and you're offering SMBIOS, but you are not offering ACPI. In this situation, you can certify your device for the IR band, the IoT ready. And a number of these Linux distros are supported, and we are investigating some of the other OSs for this band. Interestingly enough, there are still some 32-bit devices that people are seeking certification as well. But BSA spec does not cover 32-bit. So if you have a 32-bit device that are seeking certification, we are going to be providing the certification, but we're not going to be checking the hardware compliance because we don't have a spec for it. So then if you're able to support the ACPI interface for the same kind of hardware, then you can be certified as the ES band, the embedded server ready. The benefit of the IR, ES, and SR band is that they all support the UEFI interfaces. And so you can actually provide a generic OS bootloader like Grub to separate the development of your firmware hardware versus the operating systems. And also, because you have the UEFI interface, you can also support the UEFI Secure Boot and UEFI capsule services that are used for firmware updates. And that kind of is part of the new BBSR, right? The base boot security requirement specification. And if you're able to provide those interfaces, we will have the option, the security option to certify your devices as well. So in terms of the launch plan, 2 years ago, like I mentioned, ServerReady version 1.0 was launched at the TechCon. And at this DevSummit now, we are launching the SystemReady for the SR version 2.0. It is also known as ServerReady. It's just the next version of it. And then we are also launching the ES version 1.0, the IR version 1.0. We are also releasing the pre-silicon certification. In terms of the LS for the Linux boot support, we are working with the hyperscalers and silicon and system vendors. As soon as they are ready, we will be launching that as well. So I talked about the specifications for SystemReady. What about the test suite, right? So we still need to have a test suite to check the systems to see if they are compliant. So for SR, as I mentioned, it's really just the next version of the ServerReady. So we already have the ACS 2.5 available to certify SR systems. No change from the ServerReady, except that it is a newer version. And for ES and IR bands, we do not have the ACS yet. It's under development. It's work in progress. We estimate that early next year we're going to have the ACS for these bands as well. However, because the ES band is actually very close to the SR band, right? If you look at the requirements, the only difference really is the compliance to the SBSA supplement. So the existing ACS 2.5 can actually be used to certify the ES right now. We basically just choose the lowest level, level 3, to test these systems. And after the ACS is restructured for the ES and IR, you're going to be seeing this new repository on GitHub, and it will be laid out in this fashion that you can pick and choose different bands, for the testing, and even also that you can, just choose the subsets to test, maybe just the BSA, just the SBSA, and so on and so forth. It's very modular. And then in terms of the pre-silicon certification, we have been working with the third-party IP integration partners like Cadence and Synopsys. And basically, we want to address this issue that we have, a lot of the PCIe integration on the ARM systems have compliance issues. So we have been working with them to provide this pre-silicon certification so that you can check the compliance before tape-out. This would be very useful for the silicon providers. And so we're focusing on the PCIe compliance and also the performance side as well. So in terms of the certification requirements, I'm going to talk from the right-hand side because people who are familiar with ServerReady, this SR is basically the next version of it. So we are using ACS 2.5 for checking the compliance. And then, these are the specification BSA, SBSA, and the original SBSA specification to check against the levels from 3 to 5. And then the BBR side, we're checking against the SBBR requirements. And what's new in this band is that we are going to be requiring the Windows, the WinPE to be used as the OS installation check. So WinPE is a publicly available image that can be used. And then we also recommend VMware ESXi, especially when it is available in the future. And then we also are requiring 2 Linux distros. This requirement has not changed, but this time we are asking you to choose the Linux distros based on the heritage and page size, because you don't want to choose 2 very similar images to test, which wouldn't surface any issues, any additional issues, right? So we want you to choose some differences in the distros to test out. And actually 2 is the minimum, and the more you test, the better. And we are going to show the Linux distros that you tested. So the more you test, we show all of them. So this is going to be very helpful. And on the ES side, for the embedded server, again, we're using the ACS 2.5. We're checking against level 3, which is basically the foundation for BSA. And so we can use the same tool to check the SBBR compliance. In this case, we are encouraging people to use WinPE, VMware. We may actually require them in the future, but because we start this program, this band, very new this time, we're recommending them for now. And then Linux side is very similar. Choose 2, and the more, the better. And for the IoT ready, the IR band, we do not yet have the ACS for this band yet. So when the test is available, we can start the certification. Here I'm listing some of the requirements that, as we understand today, and this may subject to change. So one thing that's exciting is that ARM has been working very closely with Microsoft, originally on Server Ready and now on System Ready as well. So Microsoft supports the ARM System Ready certification program. So being Server Ready or System Ready SR compliant is the first step towards enabling Windows Azure deployment. And this has been going on for quite some time now. And for purposes of developing and certifying in the IoT space, Windows IoT Enterprise is one of the premier OSs that can boot on system-ready ES or SR compliant platforms. And as I mentioned, the WinPE can be used for the certification as well, right? It's a very good tool. And then being system-ready ES or SR compliant is the first step towards enabling Windows IoT Enterprise on the platform. So the Raspberry Pi Foundation has received the ARM System Ready ES certification for the Raspberry Pi 4 device. So this has been an open source community collaboration effort. I have the URL for this shown here. So anybody who is interested in this effort can go there and check it out. It is a wonderful effort by the open source community, and ARM being part of it. We are very proud to have the Windows 10 IoT Enterprise running fully on this Raspberry Pi 4 device. This is currently not a Microsoft-supported configuration. Microsoft currently officially supports Windows IoT Enterprise on NXP, IMX8M-based, and Qualcomm Snapdragon 850-based systems. But developers who are interested in commercializing Windows IoT on system-ready compliant ARM64 systems should contact this mailing list. We have Microsoft and ARM people on this list helping the ecosystem. And I would like to thank Robert Solomon and Jimmy Chen from Microsoft working diligently with ARM on this in this program. And also, we have a number of efforts that are in themselves independent, but are somewhat related as well. So ARM System Ready is addressing software just work on ARM-based devices. But we also have a PSA Certified program that established a common baseline for security based on 10 security goals at level 1 and focus on some of the implementation of root of trust at level 2 and 3, right? So, and in addition, for server side, we have worked on this server-based manageability requirements to support the remote management. And we have been hearing from the partners in the community that these type of remote device management is also important in the edge and IoT space. So we're going to be looking into those. So the relationship between SystemReady and the PSA Certified is shown here. So as I mentioned, we have the security option that supports secure boot and secure firmware updates. And those two features are actually very important in the PSA Certified program. And so if you're working on an ARM SystemReady device and you support the UEFI secure boot and firmware update, then you can get this security option certification from us in the SystemReady program. And with that certification option, when you go to the PSA Certified program, you already have those two aspects, the secure boot and the secure firmware update covered, right? So these two programs are connected in this fashion. So we have been working with the ecosystem to define these specifications that I mentioned, right? So the BSA, SBSA supplement, BBR, BBSR, all these specifications are going to be published along with this launch. So you can go to our website to take a look. And we have been also working with leading partners to implement and meet these standards. And security option and pre-silicon options, I have mentioned them, and so we would like to work with the partners to fully utilize these options as well. So I'm very happy to announce that Ampere has certified their Ultra reference platform, and Raspberry Pi Foundation has certified the Raspberry Pi 4 device for these SR and ES band. And we also have aligned quite a number of leading partners shown here to work with us to certify their devices under these different bands. So in summary, the intent of this program is to make software just work on ARM-based devices. We have enabled that on the servers before, and now we are extending to the IoT and edge space. Right, we would like to promote the adoption of the standards in this program along with the partners in the ecosystem. So we have launched this program at this DevSummit, and we would like to collaborate with the ecosystem and certify your devices with ARM SystemReady. So I'm going to leave you with this quote from Lyndon Van Dorn, the distinguished engineer from Microsoft. He has been the partner that we have been working with ever since the start of the specification development and the server ready and now the system ready program. I would like to thank him very much for the strong support. And there are a lot of related sessions that would touch on the system ready program. In addition to this session that I'm doing, later on today, we're going to have a panel discussion with some of the leading supporters of this program. And also many of the keynotes from ARM's executives as well as Microsoft Tech Fellow are going to talk about this program as well. Certainly as part of the Project Cassini talk. In addition, the pre-silicon certification are going to be touched upon by our partners as well. Yesterday, I talked about Linux boot with our partners with Google and Linaro, and there are also other sessions that you should take a look. And with that, thank you very much. If you need to contact me or Berenice Mann for additional information about this ARM System Ready program, I have listed the email addresses for both of us. So again, thank you very much, and I hope you enjoy the ARM DevSummit.